All right, boys and girls, we're going to look at simplifying again. I know on one of the other videos we had talked about equivalent fractions and how to find an equivalent fraction, that you could either use multiplication to find an equivalent fraction, or you could use division or what is known as simplifying. So we're going to dig a little bit deeper into simplifying on this video. One of the things is actually on this page here, which is extremely important, or I know it is in my classroom. I really teach this to my students. I probably repeat it hundreds of times whenever we are working fractions. And it's just really important to try to start learning this now at a young age, because that skill is going to stay with you over the next several years. And that is knowing when you have fully simplified a fraction. And I'm going to show that on this first example. So let's again talk about what simplifying means. You are going to divide a fraction. For instance, this first one on the page is 12/20. You're going to take 12/20 and you're going to divide by whole to find an equivalent fraction. Ultimately, you want to try to find what's called the simplest form of that fraction, or sometimes it's known as it's a simplified fraction. So you have a lot of the same words kind of being used there. So we're talking about simplifying, simplest form, simplified. All those sound very similar. So I'm going to show you with 12/20 what it could look like, and kind of that way you can kind of see, okay, am I doing something right? Am I doing something wrong? Is this a skill that I could see myself, using quite a bit? Which is, I could tell you now, it is. This is going to be a skill that is very popular. Hopefully, it's a skill that's not going to require a whole lot of effort because you know your facts so well. So we'll see. All right, so 12/20. So what I would want to think about in my mind is what number can equally go into both 12 and 20. And so right off the bat, I could see that 12 and 20 are both even numbers. So a kid might go, well, I think I could divide it by 2/2, which is true. That is totally true, because that's a divisibility rule. Since 12 and 20 are even numbers, 2 automatically is going to go into both. So if I were to do the math here and think about my math facts, 12 divided by 2 is going to give me 6, and then 20 divided by 2 is going to give me 10. So basically, you're just cutting those numbers in half. Half of 12 is 6, half of 20 is going to be 10. And so now we found an equivalent fraction of 6/10. Okay, well, at that point, you would have to stop and ask yourself, can that fraction, or can those numbers continue to be simplified? Can I continue to simplify it again? And so if you were to look at your new fraction now, 6/10, 6/10 can still be simplified. In other words, there's still another number that can go into both 6 and 10. And it would be the same rule. It would be, again, both 6 and 10 are going to be even numbers. So I technically could go and divide it by 2/2 again. And if I were to do that, I would, again, cut them in half. And I'm going to put it underneath. I would eventually find that my answer would be 3/5. And so I'm going to take 3/5 and I'm going to circle 3/5 now, because now I have found what's known as a simplified fraction. In other words, there's nothing else that can go into both the numerator and denominator except the number 1. And if you remember from our last video, or a lot of your teachers have probably been talking about this, when you simplify to find an equivalent fraction, or you multiply to find an equivalent fraction, either one, you're not going to use 1/1. And so now we've got it down to this number this fraction 3/5. So let's talk a little bit about 3/5. If you look at the notes over on the right, which these are probably some notes that you're going to talk about in class with your teachers, it says there's 5 ways to know if a fraction is in simplest form, or if it's what's called a simplified fraction. So let's look at number 1. It says the numerator and denominator are in counting order. So that means, Like if you were to just start counting 1, 2, 3, 4, and all the way up, if they were in consecutive order back to back, you know that you have a simplified fraction, like the one they gave you as an example, 7/8. Well, our fraction 3/5 does not meet that requirement, but maybe it meets another one. So let's look at rule number 2. It says there is a 1 in the numerator, like 1/8. Okay, so 1/8. 1/8 has got a 1 in the numerator. That is another good way to spot a simplified fraction. Still not us, though. Look at 3. Both the numerator and denominator are prime numbers. Their example is 3/5, which is exactly what we have. We have, basically a simplified fraction of 3/5 because at this point, if I look at it, I could think of it as, okay, well, both 3 and 5 are prime numbers. There's not going to be anything else that can go into both 3 and 5, so technically I am done simplifying. The fourth rule is the numerator is prime and doesn't divide evenly into the denominator, like 7/15. So 7 would be a prime number, but 7 can't go into 15, so you'd stop there. You can't divide that anymore. Or it says on number 5, the GCF of the numerator and denominator is 1. For example, like 4/15. Okay, speaking of GCF, let's talk about something. So I'm going to try my best here to leave myself some room, but I'm going to use some more of the page here for 12/20ths. So let's link it back into factoring and why we spent some time factoring in class. So I'm going to go back and pretend if I had 12 and I had 20 and I wanted to factor both of those numbers, what I could do is I could factor them and I could find what's known as the GCF. Okay, and you guys probably remember doing that, the greatest common factor. So I'm going to show my work here. So I know it's going to be 1 times 12. I know it's going to also be 2 times 6. I know it's also going to be 3 times 4. That's going to give me all the ones for 12. I'm going to have 1 times 20. I'm going to have 2 times 10. I'm going to have 4 times 5, and that's going to give me all the ones for 20. Well, here's why I'm doing this. I want you guys to really think about the connection here. So what I did in my work on 12/20ths was I divided it by 2/2, got an answer, but then I had to divide it by 2/2 again. What I want my students doing, and I'm pretty sure all the math teachers, they're going to be the same as me, I want my students to try to work smarter, not harder. And I want them to find that greatest common factor first, and then from there, maybe not have to do as much work. So I tell you what, I was going to do 2 problems on this page. I think I'm going to just erase the 3/21 that I had put underneath, and I'd rather just show this again. So watch what happens now. So if I took 12/20ths, and instead of thinking about, okay, well, I think 2 can go into both 12 and 20. What about if I had done the GCF and I divided it by 4/4? Well, watch what happens. 12 divided by 4 is 3. 20 divided by 4 is 5. And I get the same answer, but with much less work. And I can tell you, and I don't mind saying this because I use this a lot in my classroom, but when I was a kid, I was that student that sometimes would work harder and not smarter. And I might be this kid up at the top of the page having to do a lot of work. I might get the right answer, but I might have to do more work. We want our students to be proficient and be really good at what they're doing. And so we suggest, hey, learn those facts. And if you learn those facts, those greatest common factors are going to probably just become naturally to you. And so when you see that the greatest common factor is 4 can go into both 12 and 20, you get the same answer of 3/5. You just get it a lot faster. What's interesting, though, is I'm going to circle this. I'm going to change colors. If you look here at the 2 that we did at the top, the 2 things that we chose at the top were to divide it by 2 and then divide it by 2/2 again. Well, if you think about it, what is 2 times 2? 2 times 2 is 4. Well, 4 ended up being the GCF. Now, had you just done that to begin with, and I know this is just a video to help show you guys, but if you were to do that to begin with, you just have a lot less work, a lot less headaches too. And so that's what we want our students to do when they simplify. We want them to get it down to the lowest numbers possible. Basically, what's called the simplest form or a simplified fraction. All right, on this page, I just put a couple examples here. I'm going to show both ways again, how we would want this done. I'm going to show first, I'm going to take 16 and 20. And so I'm going to kind of show the long way here. This is not the wrong way, this is the long way. So hear me out. So the long way would be, okay, I've got to come off to the side, I've got to factor, and I've got to find all these things that could give me these numbers. So I think I've got 16. I've got 1 times 16, 2 times 8, 4 times 4. All right, and then for 20, I'm going to go 1 times 20, 2 times 10, 4 times 5, and then I think I'm done with 20. And so from here, now I can look at 16/20ths and go, okay, I think my GCF is going to be 4. And so I'm going to come over here and I'm going to put my division symbol and I'm going to divide by my 4/4 or my whole. Remember we talked about that on the previous video. You're dividing by a whole there to get an equivalent fraction. So now I'm thinking about those math facts. I've got 16 divided by 4 is 4, 20 divided by 4 is 5, and now I know I have a final answer. The reason I have a final answer here is it's one of my rules from the previous page. It is simplified because I have a fraction in counting order, or it's in consecutive order. If I were to count 1, 2, 3, 4, 5, since my numerator's 4, my denominator's 5, I know I have a simplified fraction, or I have a final answer. Okay, so that's one way to do it. The other way to do it is actually just knowing your facts. So what I might do on this bottom one, if I were doing it in class, is I might just put that up on the board and say, okay, let's try it. Let's see who knows their facts. Okay, well, what can go into both 24 and 30? And so we'd probably have a discussion. I'd probably have different answers. I could tell you one of the most popular ones that would be shouted out would probably be 2, which is correct. 2 can go into 24 and it can go into 30. But I don't think 2 is the GCF. I would want the GCF to be found. So if you thought about it and you think real hard, I think the GCF here is going to be 6. I think 6 can go into both of these. And if I show my work here, I think I end up getting, ironically, I didn't even mean for this to happen, but ironically, you're going to get 4/5 again. So if I were to look at 4/5, same as the one above it, I'm looking at this and I'm going, okay, well, 4/5. 4/5 is in consecutive order. It's in counting order. So I know I have a final answer. Now, honestly, this is what I tell my students. Whether you're that kid that has to go show your work and go through all your steps and factor and find that GCF, if that's you, that's you. And there's nothing wrong with that. But I know in my classroom, at least, I would want the kid at the bottom of the page by the end of the year. It's going to require you really knowing your facts and getting in a lot of practice. But that's something that by 5th grade, you should know by now. And you should know those multiplication facts. So I want that kid that's not going to work themselves to death. I want that kid that's efficient. They know, hey, 6 is going to go into both of those. Let's use it. Boom, I'm done. And so that's kind of where you're trying to get to. And it's going to, again, if you're not there at the beginning, it's not the end of the world because this is still new to you. But that's where you want to try to be. And so that's kind of what I always tell my students. I refer to my students a lot of times as 6th graders because you're so close to being 6th graders. That's what 6th graders can do. 6th graders can look at 24/30ths and almost know in their mind, okay, hey, 6 can go into both of that. That's going to give me 4/5. And they can almost do it mentally. And so that's kind of the ultimate goal. We still want to see your work. We want to see your work on paper, but that's really where you're trying to get to. All right, this last page here is just going to show some examples of something that you could see. I may not do all of these because of time, but what could happen is you could have some fractions that have missing pieces. In other words, there's like a missing numerator or there's a missing denominator. And so I'm going to circle a couple of these that I'm going to look at, and we're just going to kind of talk about what you would think about here if you ever were to see something like this. First of all, I'm just going to put an arrow here. We're still thinking about equivalent fractions. We're thinking about something that is the same or it's equal to. So what they've done here is they've taken a fraction, and this problem here is they took 5/30ths and they found an equivalent fraction and they left off a numerator basically. And so they're saying, okay, 5/30ths is the same fraction as something sixth. I just don't know what that something is. So I'd have to think about, okay, well, how did they get that? So a lot of times in this case, I would use the word relationship. There's a relationship between the numbers. Between 5/30ths and then something sixth, I have to see that relationship. In other words, I have to see, it's kind of like, okay, well, how did they get it from here to here? And so I'm thinking they simplified something. So I'm just going to kind of barely write in a division sign there. And I would have to think, well, how did they go from 30 to 6? So if I'm thinking about that and I know my math facts, I think they probably did 30 divided by 5. And I'm going to write in a 5 there, which means if they used a 5 there, then a 5 would have to go up top as well, because that would make my whole. And then now I can fill in the blank, because 30 divided by 5 is 6. Well, 5 divided by 5 is 1. And so my answer here would be 1/6. That would be my final answer. And that falls under that category of a simplified fraction because it has a 1 in the numerator. Okay. The next one, number 2, same thing. I'm looking for a relationship between the numbers. So how does it get from this number to this number? So I would ask my students, well, how does it get from 4 to 1? Well, I still think they're dividing something because they're getting lower numbers. They're going from 4 to 1. So I think that they're dividing 4, and they're dividing it probably by 4 because you're getting the same thing, or excuse me, you're getting 1. And so I'm thinking here maybe they just used 4/4 as their whole. So 4 divided by 4 is 1. And then it would be 28 divided by 4, which is a math fact. And I fill it in with the answer there, which would be 7. So your final answer or your fraction there that would be equivalent would be 1/7. So again, just a different way to see simplifying or to see equivalent fractions. I really, really think though that this, again, like I said at the beginning, this skill, this type of problem is very, very popular. It's very popular in 5th grade. It's very popular in the next few grades. So it's really important that you get it down, but you really have to practice for it to really click and make sense.